So this is a story about three different things used in this course called bioaerial locomotion. The course itself was non-traditional. It's an engineering course, introduction to engineering course, but we covered a lot of biology and evolution and things like that, which was unexpected for the students, quite unexpected for them. Let's see if this works. So the aims of the course, I was told to do an introduction to engineering course for the people who are interested in the aero concentration based on the general idea of how things fly. So this was, normally one would have chosen to explain how airplanes fly, but I decided to use the opportunity to motivate bio-inspired engineering, seeking examples from nature of the desired function, in this case, using flow for producing forces through gliding, falling, or flying. And there was plenty of opportunities to link this to robotics and many new applications of engineering. So the course itself, the course topic, was already somewhat unexpected for the students. The first element that I used is screencasting, and following from the previous presenter, quite a bit the same idea, which is recording the screen of the computer while producing a presentation. The difference is the presentations were produced in class. So as I was presenting to the students, I used slides, but PowerPoint slides are so static and they're so boring and nothing happens. And so to combine them with the interactivity of the old-fashioned chalkboard, I use very simple slides that simply have a title, an image, an equation, and then as I am going through any material, I would annotate the slides with what's called digital inking, simply using an annotation software, free stuff all the way through, with a graphic tablet. Indeed, I pay for that one, but it's a little bit of hardware. People can use, of course, tablet computers for the same purpose, but I'm a Mac, as I said. So the tablets are still Windows, except for the iPad, but the iPad doesn't have a handwriting yet capacity like I would wish to use. So I'm recording the screen at the time I'm doing this, and the screen at the end of the lecture I hit stop, and I have a complete recording of the lecture with the slides up here, with the my slides, my annotations, and everything synchronized. But I can also embed media, which I cannot do on the chalkboard. So I can show them this video and motivate an idea, what's happening there, and then I can have a discussion, because I have the opportunity with the PowerPoint, or in this case, in my case, Keynote, to embed rich media and combine that with the capacity with the digital inking of doing mathematical notation. So that's the first ingredient. At the end of the lecture, I have, as I said, a full recording, and I can very quickly upload that to iTunes, and so all of the lectures are on iTunes U for the students to watch at their leisure for replay and recall. In addition, for the whole world to see, so it's a little bit unnerving because, of course, you make mistakes in class, but when you let go of that, it's okay. And most of what I've received in terms of feedback from people, this is not my only class on iTunes, and so you can see in the bottom, there's two other classes being listed there for BU. That's my fluid dynamics class from another semester, and my computational fluid dynamics class from another semester. They're all on iTunes, and I've received emails of appreciation from Libya, from all other places, from old gentleman from Arkansas wrote me an email saying he was very happy that he could learn finally fluid mechanics through my lectures. I think he said he was around 80 as well. Somebody said something about learners of that age. The other ingredient in this class is the course blog. So I wrote some articles about the course material that I posted there. Here's like the index page of the course blog with my posts there, and also the students. It goes way down low, below there, with all of the students and what their contributions were. They had an assignment. They had to write a blog entry about the course material, and this was part of the assessment as well. So the reason for the course blog is that this unit, Introduction to Engineering, has a communications component, and so I used the blog for this communications component. They had to write there, instead of writing an assignment, written essay on a piece of paper. And I thought this would also teach them some new modern communication avenues in terms of communicating on the internet, and I was able to motivate things like fair use on the internet and Creative Commons and how to cite other sources and use images properly and so on. The other reason I chose the blog is that I read this essay. I don't know if anybody here read it. Anybody saw this blog post that appeared in July last year called "Why I Will Never Pursue Cheating Again"? Anybody saw it? No? This was major. It went viral in days, and I saw it literally within days that it was published. But a New York University lecturer posted this. It had some repercussions, and the university required him to withdraw it. But that's very funny when somebody wants to actually retract something from the internet, because of course nothing can be retracted from the internet. You can find this, of course, on the cached versions, and I will invite you to just on your own Google it if you're interested. But the conclusion of this post of this lecture was that he just turned it in, and he put the assignments and turned it in and started looking at the plagiarism cases, and he discovered that by the end of the semester there were 22 cases of admitted cheating, and this has used a tremendous amount of his time, and he was exhausted, and of course the class atmosphere was terrible, and he decided he would never pursue cheating again. He was just not going to do it. He instead proposed to use other types of assignment, for example, public projects. Public writing. I thought, oh, cool, so I'll have them write on the blog. It's public for everyone to see. And I told this at the beginning, your writing assignment is public. Your friends will see it, your parents will see it, your classmates will see it, anybody in the world can see it. So if you copy, and if you copy from Wikipedia, then it's your honor on the line. And so they responded quite well to this. But also, yes, indeed, because they have an interest, they're very preoccupied about embarrassment, and this, appeals to their sense of public persona. So this works, but another interesting thing happens is that communicating on the internet, they use a much more casual tone. And when you would have received an essay written with a lot of jargon and perhaps overly obfuscated, when they're writing on the blog was much more friendly, like they're talking to their peers. So it was a very interesting thing to see how they communicate on the internet. The other aspect of this course was the use of guest speakers, and I'll give you a quick overview of the speakers that I used, because I'm talking to engineers. I'm an engineer. I'm talking to them about biology, about how creatures fly. And so I had several people from around the country join in the class via Skype and be interviewed by the students about a particular case. So Professor Steve Janowiak, he discovered the gliding ants of the tropical forest. These are ants that fall from a tree and are able to maneuver in the air with their feet and always land on the trunk of the tree and climb right back up home. It's amazing, an amazing discovery that appeared in Nature, the gliding ants. Here is an ant in its skydiving posture right there, captured by a student in a little wind tunnel. And this is a screen capture from Professor Janowiak using a toy ant to explain to the students the posture of the ants. I could have told them the same thing, but here was the guy who discovered it telling it to them. They were fascinated by this. It's the same material, and they asked questions. So Steve Janowiak talked about the gliding ants. Dr. Arden Husufi talked about the falling gecko, the geckos that fall and at 100 milliseconds are able to right themselves and always fall on their feet. This is a conservation of angular momentum, air riding mechanism, and this is the guy who discovered it and was able to explain to them how he discovered it, the students ask, what is it like to work with animals in the lab, and things like that. And they get a feeling for this sense of discovery through interviewing the person who actually did the discovery. Via Skype, I also interviewed Professor Jake Socha, who discovered the gliding snakes. We talked about the gliding snakes. The snakes are able to fall from a tree and glide by flattening their body. They get a flat belly by opening the ribs up, and they just become a wing. Their body becomes a wing. Professor Robert Full of TED Talk fame talked to them about the geckos as well. They loved this. Jonathan Monk also works on the gliding ants, also talked to them. And finally, Professor Robert Dudley, who is an authority on the evolution of insect flight, talked to them from the point of view of evolution of flight. It was that was a very good session. So let me end just by showing you this sample.
What is it about the gecko? Is this animal just very lucky with its adaptations, or what?
Well, I think I'm in seeing the incredible diversity in biology. I would argue that all animals have secrets that are pretty cool. We just don't know about most of them, and we didn't have the tools in the past to study them very well, to understand them deeply rather than just sort of behavioral description. And so that's what's changing in your time, is that we can go after these bizarre adaptations we see in so many different organisms. And so we work on other ones too. I mean, we work on cockroaches, and they have an equally crazy set of adaptations that are extraordinary, that we now can quantify and transfer these principles. And so what we say, I think, is that there's a sort of a library of design ideas out there in different organisms. You just need to find the right one that helps answer the questions that you have. And importantly, although I think we should destroy the environment. I don't want to see polar bears go extinct. But another reason to think about conservation and issues with climate change is to realize what you're saying is that, wow, all these animals have these incredible secrets that can give us direct benefit if we can understand them and apply them. And it's a risk if they go extinct, because these secrets could be lost forever. So we don't want to do that, and all the animals have such strange things. That's why I think it would be good if you can do it in your schedule to try to take a biology class and look at some of this diversity, because there are other animals that are going to inspire you and can give you the novel idea that produces the competitive advantage that you have in your lab if you go into academia, or in your new startup when you create your wonderful new device that you're going to sell.
And you mentioned cockroaches. What's special about cockroaches?
No, I don't have enough time to tell you. We spent 25 years working on them. I'll tell you the most recent wacky thing that we found. You can look this up. There's a news article on it in Science magazine from 2 years ago. I think it's called Crash Happy Cockroaches or some crazy title like that. The most recent thing we found is that cockroaches we tried to look at them climbing up a wall, like the geckos, right? And they did it, and no problem, but we heard a sound when they did it, like this. We thought, what is that? And we discovered that they crashed head first into the wall on purpose. Which is, you can slow it down and see it, which is crazy. They can run 1 meter a second. So they're only this big. They're really fast. So any lighter vibration, they're so fast you can't possibly see them, which is why you think you don't have them in your house. And they're incredibly fast. They hit the wall, and then they transition off the wall in 75 milliseconds. And so they use their bodies, essentially, to absorb energy and to smartly transition off the wall, rather than relying on their sensors, their antennae and their eyes, which would have to work in a very short period of time to be really effective. So they use their exoskeleton. And so it's kind of a mechanical mediation of dealing with a transition up the wall. Well, we've made a robot do that by making the bodies compliant. So there's a whole new manufacturing process called smart composite microstructures. You might want to look up, because you make any flying device, you should make it out of this too. But it's like origami. You laser cut the material, you laminate it, and you fold it up, and you can get as many degrees of freedom as you want. Different joints, you can build these things in a day, and you can create new robots, smart composite microstructures. Totally cool way to do it. So we found that bodies, that when they're small, they can absorb impact. Well, this has changed the group in Switzerland from EPFL which I'm going to next week to talk to, who has a whole robotics institute, that instead of building flying robots that maneuver really carefully and precisely around things, they put exoskeletal cages around them. So they smash into things, land, cages so it orients it the correct way, and then just takes off again. And it can get through terrible obstacles, but that's because crashing isn't a failure. It's actually a strategy when you get small and you think about exoskeletons. And so the crazy thing is that now a company, which name escapes me, has used the material of the exoskeletons called chitin to make the next generation car bumpers, because it absorbs so much energy, and they just signed a contract with Ford to do this. This is a chitin biodegradable bumper that uses these techniques. Now, who would have thought that studying a cockroach with its weird adaptations like this would lead to that idea? But it does, and it's increasing all the time. And so it's very exciting on both ends, both biology and engineering, to have these kinds of interdisciplinary interactions because all groups benefit. We discover more stuff, and you get a lot more ideas to basically change the path of engineering.
So, by having these guest lectures talk to the students in that way about their discoveries, I think it gave them a sense of discovery and a curiosity about as engineers working collaboratively with other disciplines that I couldn't have possibly done on my own. Of course, I'm very lucky that these very famous, indeed, Professor Full is quite famous and busy, and Professor Robert Dudley and so on, volunteered their time, but they're educators as well, and I explained my concept. I'm an engineer trying to motivate bio-inspired design in freshman engineers, and they volunteered their time. So this is the third ingredient, and I'll be happy to entertain questions now.